So that was the most basic way we can find greatest common factors. We can just list them out. With least common multiples, the most basic way we can do this again is we can just make a list. We can just list them out. It's important to understand that factors break down numbers into smaller pieces. Multiples grow numbers into bigger pieces. So when I talk about multiples of 6, I'm going to start with 6. Plus 6, plus 6, plus 6. So I'm skip counting by 6's, and these are all represent multiples of 6. And I can keep going, 36, 42, etc. For 20, well, I've got 20, 40, 60, 80, okay, and I can keep going. With 30, I'm going to skip count by 30, 30, 60. Oh, so I'm looking for what's the smallest number that's common to all three. Well, I can see that 60 and 60 are common here. I haven't quite got to 60 here, so I'm just going to keep skip counting and see if I hit 60. So 48, 54, 60. So there we go. We have now found the first multiple that is common to all three. The first multiple is going to be the lowest, so our lowest common multiple works out to be 60. Okay? It's the smallest number that we get to when we grow the numbers, when we make the numbers bigger. So these are kind of fairly straightforward methods of finding GCF and LCM. And if we kind of forget the more sophisticated methods, we can always go back and rely on these ones. However, these methods are a little bit inefficient. So we want to see how we can do this a little bit more efficiently. And we can do this by looking at prime factors. Okay, we can look at the prime factors, and we can use the prime factors then to find the lowest common multiple and the greatest common factor. So the method that we're going to use is fairly similar for both greatest common factor and lowest common multiple. We're first going to prime factorize. So we're going to make a factor tree. So when I prime factorize 40, so I'm going to compare 40 and 168. I want to prime factorize 40. Okay, so I'm going to end up with 2 times 2 times 2 times 5. So 2 times 2 times 2 times 5. Just going to write that a little bit over here. And I can do the same for 168. Okay, I'm going to do 168 as a factor tree. So I'm going to end up with 2 times 84. Okay, and then this will be 2 times 42. 2 times 21. And 21 factors to two prime numbers, 3 and 7. Okay, so those are my prime factors. So I'm going to rewrite this as 2 times 2 times 2. There's 3 2's times 3 times 7. Okay, so I first of all prime factorized 40 and 168. So what I'm going to look for, I'll do greatest common factor first. So if I want to find the greatest common factor, well, what I've done is I found all the factors, and if I want the biggest factor that's common, what I'm going to look for is all the common factors. And since this is all multiplication, okay, so nothing else is in common here, I'm just going to take the common factors and multiply them all together. Okay, because I want the biggest one. So if this is common, I've got a 2 that's common, I've got another 2 that's common, I've got another 2 that's common, and I want to grow this into the biggest common factor, and it gives us the greatest common factor of 8. So we take all the common factors, and these are prime factors, and combine. So in this case, the greatest common factor is equal to 8. Okay, so that's how we find the greatest common factor. So we can use this as well to find lowest common multiple. And so lowest common multiple is going to be done slightly differently, but we're still going to use these prime factors. And what's going to end up happening is we're going to do it this way. So when we talk about multiples, if I multiply 40 times 168, that number is going to be both a factor of multiple of 168 and also a multiple of 40, because by definition, if we multiply them together, the product is a multiple of both numbers, and that's a common multiple. But that's a really big number, and we don't necessarily want the biggest multiple. We want the smallest. So we want to be able to make this smaller if we can. And to do this, what we can do is get rid of some of the common factors. So if these two numbers have a 2 in common, we don't need to use it twice. We just need to use it once. Okay, so I just take one of these. Again, I have common 2, so I'm only not going to use both of them. I don't need both of them because I have one here, so I only need one of these to grow this number. I take one of those common 2s, so I have a common 2s, which I'm going to get rid of. And then anything that's not common, we have to use because we need to have these multipliers to make these individual numbers. I need the 5 to make multiples of 40. I need the 3 and the 7 to make multiples of 168. So I have to take one of these, one of these, one of those. And once I've done that, I can just combine this all together, and then I can find the lowest common multiple. So when I multiply this all together, I'm going to end up with, it looks like 840. I just have to double check my math here. So 21 times 5 is 105, times 8 is going to be 840. So this then represents the lowest common multiple. I multiply all the factors together, but I get rid of the common ones. Okay, so this strategy also works in this way. I can multiply this, so that, try to understand, this is a parallel method that's essentially doing the same thing, but we can do it a different way. We can multiply together, and then we can get rid of all the ones that were common, or we can get rid of the greatest common factor by dividing by the greatest common factor. So if we do 40 times 168 divided by 8, and go ahead and try that on your calculator, you'll see that we get the lowest common multiple of 840. So the LCM works out to be 840. And essentially what we're doing is we're multiplying these together and try to get rid of multiplying all the factors together, but we're eliminating some of the common ones.